So, hello everyone. Yeah, I'm Guillaume, and I will speak about two things, so RAG and about scikit-learn. So just about me to know who I am. So yeah, that's very relevant now. I have a PhD in medical imaging, but I mean that's useless. And afterwards, now I'm open source software engineers at Probable, depending where you are from. And I'm a core dev of scikit-learn and a core dev of imbalance-learn, which is another libraries as well that checks some other aspect of scikit-learn. And that's my GitHub. So, motivation for that talk, and is a kind of a different RAG talk, I hope so, which will take basically the RAG under another angle. So basically you have like many talks here. If you want to know how to make a RAG, you can go and they will explain you. Here, what we wanted I mean, the real motivation is that we have this scikit-learn website, which by the way, it doesn't look like that anymore because we released like a new version yesterday and it's much better. But the search engine, which is on the top there, is kind of very limited still, even with the new versions. So basically, when you want, what we wanted to know is like, can we do better than what we have? And I will just like motivate what are like the limitation of this search bar. So the limitation that you have is if you just make a search and that you make a mistake, then it doesn't find anything because we make exact match. Okay, so we all do mistake when we type, so this is a bit annoying. So if we would have like kind of fuzzy search, that would be much nicer. And if you go in the natural language way that you would expect that if you type a sentence, then you will find like the matching like page or whatsoever, that doesn't work very well as well. So we match some words, but basically that doesn't understand like the meaning of the sentence. So in this way, we wanted to have a kind of, maybe everybody is speaking about LLM, so scikit-learn doesn't do any LLM, but maybe we can like look at them and see what they do. So the idea was to improve the scikit-learn user experience. If they use like this search bar, maybe we can propose like a new thing that will be super cool. The second thing is that I wanted to learn a bit about LLM because everybody was speaking about that. And last thing is like I really wanted to come here. So yeah, that was nice. So let's see. So first slide just to give some concept about RAG in case that you didn't attend any talk yet about it. So here, when before to speak about RAG, I will speak about how we deal, what is the framework that we deal with basically here. And it's more about zero-shot prompting. So you have ChatGPT, you ask a question, is answering to you. Okay, that's what we are here. And the way that we have that is that we have a model, and then the model can be either on Mistral, because you are French, Meta or OpenAI, and then you can either like go programmatically because you have like the model on your laptops or locally or on the servers, or through an API if you have OpenAI. Okay, so you can ask the question there. And then you have the front end, basically, that just make like the discussions and the message going through. So what is a RAG here? The RAG is just before to answer the questions, you will just go through a database where you want to find context of document where you are interested in, and like find those documents and provide them to answer the questions. So you will not anymore ask the LLM just the question, but you will say answer the questions with this context that should help you to basically to answer these questions. Okay. So in our case, it's typically a user will ask a question about scikit-learn, so we know that they should come into the scikit-learn documentation somehow, and they want to find where the things are. So probably if we can find what they want from the documentations and provide that into the prompting, then we can better answer the questions. So if we look at more precisely like the information retrieval, so now instead to have one program, we have two, okay? Because before we had the LLM program, now we have information retrieval programs. So we can look at like the second part that was the information retrievals. And let's say the big picture is the following: is we have the questions. In some way, we have to vectorize that things. Okay, so go into like numerical space. And then we have a database where we already vectorize content from the documentations, and then we want to retrieve through that database the closest, basically, vectors, and then go back to the original context. Okay, and this context that afterwards will pass to the prompting. So here we'll see several methods that you can use, and we use basically two approaches, but that's the general idea of the information retrieval. And this is not new. Okay, this is like research from, I mean, Google was doing this. Okay, so this is like already 60 years that people look at these things. Okay, so what about the RAG? That should be a fairly easy thing to do, okay? So we do all talks because it's that easy, that's why we speak about it. And if you look at the internet, this is very easy. You can do a RAG in 50 lines if you listen Scaleway, but you can do it in 4 lines of code if you do Clarify. You can put it in production depending of like if you use LaMindex or any scale. And if you are Mistral, basically, you can do in like with all the different library that you can find. So it seems that this is something very easy, and the difference between, I say, my talk and those talks is that I'm not selling you any models, okay? I'm not Mistral. I'm not selling you any computes, okay? So I will be critical on what it costs. And I'm not as well writing any library. I don't really care, okay? So here the idea is how useful, how possible this is to put it in production for in a perspective of an open source project. But I put as well some rules of what I wanted to do. Okay, so first this is a POC. I'm far to be an expert in LLM. Okay, that's not my things. What I didn't want it to do is to pay money. Okay, so I'm cheap. So I wanted to develop something on my computers, like make a POC that can run. I didn't want it to bother with API of OpenAI or stuff like that. Okay, I wanted to have like my model on my laptops. I wanted only to write Python codes. I'm scikit-learn person, so I wanted to have my scikit-learn API in some way. And just to understand basically the tool that I was manipulating, I didn't want it to use a wrapper of wrapper of wrapper of wrapper. I wanted to use like let's say bare bone things and just put my own wrapper on the top. Okay. So, and the idea was just to like have this set of rules and see what we can do with that and what are the tools which are available and where we can get started and having something working very well. And of course, I needed to find a cute name, so I call this RAGaduck. So all the experiment that I will speak or whatsoever is available on that repo with this QR code. So if really you want to run it locally, you can always do that. Okay, so you can like take the repo, like train the retrievers, and then you will have a version of scikit-learn that is there, and then you can even ask you questions, okay? Hoping that basically it doesn't burn your computer. So that's, and the only thing that you need to know is that it's not smarter than a rubber duck, okay? That's, so what did I use there as stack? I used so several stacks that are up there. So I will go a little bit more into details in the information retrieval, but basically the library are just pick up from a bit everywhere. So I use Llama CPP with Mistral because I'm French, so I say, okay, let's use the French people in Paris. And I use Llama CPP, but of course there is over interface. You could use VLLM, sorry, and do whatever. I mean, it's not the one that are like I didn't make the choice because they are performant. Okay, I just make the choice because they were easy to use, easy to compile, whatsoever. So I use Llama CPP Python for that, and then in the information retrieval, I use sentence BERT and face. That's the same. You have stuff that are much better than face nowadays. And otherwise, I just reprogram as well some of the estimator like BM25 because there is no implementation out there. So I just like re-implemented that one. And for I'm not a front-end guy, so somebody did that, and I just like took it. It's in REST API, and it worked very well, and I just like modify it and make it as simply as possible. Okay, so let's dive into like the RAG part. Okay, so how do you build basically the database, and what are the important things there? So if you read like the document that do a RAG in 15 lines of code, they will say, take your documents and you create chunk, okay? A chunk is just like a piece of text with an overlap and everything will work, okay? So great. However, so we can do better than that, and I will show that if you do these exact things, yeah, you have something working, but it doesn't work. And in scikit-learn, we have as well 3 types of documentation that we can leverage. So I will look at the first one and try to think what are the problem that you can have, like with the chunk strategy that we have before. And then we can think about like the different type and what we can do to improve that. So the first type of documentation is the API documentation. So it's looking like this page where you have the class name, the parameters, the description of each of the parameters. And if you're an engineer, the first thing that you should think of is what type of question should I answer as a user? I mean, what if they visit that page, what questions they can come with? And usually will be what are the parameters of the models? What are the value of that parameters? Or like things linked to that, okay? And the very interesting thing is if I use just like a normal retriever and by checking like with the chunk that we have before. And I want to answer to that specific question, which is like what are the value of the strategy parameters in the dummy classifier. I will get match of words that are along basically the strategy, okay? And then you will find me like chunk. And for instance, I will find a chunk about strategy for the dummy classifier, which is actually the one that we want. But then I will find as well for the dummy regressor, okay, because it's also like they are the same parameters, so without knowing the context, that will come up. And the same with a simple imputers, because we have as well like the same name, okay? And the problem is that those chunk here is what you are providing to you to answer the question to your RAG. So your RAG will come and without, let's say, more information, you just give those chunk. Then it's completely failing by telling you that, okay, the strategy parameter doesn't exist, which is like, I'm sure that that exists, but okay. And then it's just telling you like he's just mixing like things together. So by telling you like wrong things and even making like some grammatical errors in the middle, which I have no idea why. But so how can we just like this? So here there's a problem of ambiguity because we have the same parameter that come in different piece of information, and somehow we need to provide chunks that could help basically the models to disambiguate the informations. And here the easy things that we can do is because we are using NumPy doc as a standard. So here these are documentations, and the way that the API documentation is written is following the NumPy doc standards. And it comes with a wrapper. So we can easily get a structure, the information structure by NumPy doc. And from that, we can recreate chunks where we can inject, for instance, that, oh, the chunk that you will have is coming from that specific class. So that's already solving the problem for the LLMs, okay? And then in this way, you can find some strategy where you just like create different chunks with the informations. And if you provide those chunks to answer the original question, in that case, the models start to be able to disambiguate, okay? And the first reason as well that I should have mentioned is that Mistral 7b probably have never been trained on the API documentation of scikit-learn, so that's why it was not able to answer the question at the first place. If you use already like a huge model, probably it was trained on that, and then you don't even need the RAG because you already saw the information. So here it was, this is one of the things. Okay, so other type of documentations that we have is the user guide. The user guide, in that case, we could have, I did, because I did exactly the naive chunking. I could have done a bit more by actually finding the sections and being sure that when we chunk in a good way, okay? But here I didn't take care. And I don't use the images as well. And then we have another thing, which is the example gallery. In this case, we use Sphinx Gallery, and then Sphinx Gallery also allow to like find different part of the documentation and the section. And in that case, I use that to create the chunks. Okay, so it means that I will have a sections which usually the context inside that sections is meaningful with the code associated to it. Okay, so I really use that. And I have two types of documentation, one that is usage example, one that is tutorial. So the usage is very like, you have a single section. So here we just make blocks, and the other one just like find the sections. So regarding the retriever, so how do you, one that you want to, you have your chunks, you want to create your database. And here you have two solutions. You can either go with lexical search. So this is the BM25. So the idea is to look at the word, how many times they appear, and then you create a sparse representation of that. And when you have a new document, you just like count the word, and then you check if there is one vector that match depending on the score. Okay. So this is like very cheap. This is easy to get like the invert indexing case, but there is no semantic. Okay, so it doesn't understand the semantic. It's just looking at word occurrences in that case. And then you have the semantic search, which is like through the BERT models with pre-trained embedding. And in that case, it's much more complex to compute the distances because the space is dense. Okay, it's not sparse anymore. So it's much better in terms of finding meaning in the sentence, or in the document. But you need to have approximate nearest neighbors probably to find the vectors. Okay, so that's why we need face in that case. So you have those two things, and we just try to make those two search and combine the results. So it's a piece of code just to show to people how that works. So in some way, here I have a scikit-learn pipeline where I'm using the convectors, and then I have a retriever where I need to pass basically the convectorizer. And before that, I have the API scraper. Okay, so it's a pipeline with like different steps. I just need to feed the documentations, and at the end of my job here, I just need to dump, basically to PyCon, the retriever. And I can do exactly the same for the sentence retriever, and with the same extraction stage, like fitting the models and then like dumping the models. And I have a final stage where I will have different chunks coming from the different retriever, and I need to re-rank depending on the positions. And you have like cross-encoder that can help you here. Okay. Prompting, nothing new. Okay, you're an expert. You need to answer to my things. Just use this context. And if you put everything together at inference time, it looks like something like this. Okay, so you load all the models. You have the cross-encoders just to get like the different to reorder basically the queries. And then you pass this to the llama index, and you ask to answer using those retriever and this LLM just answer to the query. And this is basically what's run there. So just as demo time, just to show that it works. So I have an instance somewhere. Thank you. So I'm using Pixie. You should use Pixie. You should like look at what it looks like. And so start Rager duck. CUDA. Okay. And so the idea here is that you load the models. Hoping that you have internet. Yeah. So is what Ragged look like, and then you can ask your questions. What are the parameters of logistic regressions? Even with typos. Make me quack. Okay. And then, so this is pretty fast because this is running on the GPUs on a machine on Scaleway. But if you look at the log, basically, what happened behind the scene is that's my prompt. And just before, are the retriever. So basically, we pass like the question to the retriever. We just get back all the different chunks. And here, this is my prompt. So this is the start of the prompt. And then we just pass the source and the query. And then the model is just answering like, OK, what are the different parameters? And then like putting you the source that basically you find. OK? And in that case, you just run that. So this, you can run it locally as well on your laptop. This is exactly the same. So 2 slides. First, evaluations. There is none. Okay, so it's where this is starting to be complex. So we are an open source project. If we want to really evaluate this, so what people do usually is that they will ask ChatGPT the same question. They say, yeah, we agree with another LLM, which is for me very disturbing. Okay, so if I want really to know how I solve a problem of a user, I need to collect data from users, and I need to check on those. Okay, otherwise I don't know what I'm looking at. So for the scikit-learn project, we decided that we'll never acquire any data from users, even if we are GDPR. We could be GDPR compliant on there, but we don't want to bother with that, because in case that we leak any data, we don't want to bother with this as well. Okay, so we don't want to do that. But it makes that it's impossible to evaluate the RAG, and it's impossible to fine-tune any component. So maybe for use case here, we could say we can publish this app somewhere, and if you want to opt in, then we'll collect your data, and then we will make this open to everyone, and then you can use a better LLM. But it's not the case for scikit-learn here. And the second thing that I didn't speak here about, but I think I have inside the final thoughts, is the cost. We are poor open source projects, so if we need to use some like scale GPU to retrain or fine-tune, we don't have the money for that. And if we need to serve the model itself at the inference time, we need 1 GPU. If we have we have more than 1 million users a month that look at the documentation. If everyone start to do queries, you start to make the numbers, we might need a 10,000 euros check just for people playing with something online. Okay, so it's fine with OpenAI if you have subscriptions, but on our side, that might be complicated as an open source project to actually. I mean, this is not affordable. Okay, a part of if people give us like free resources for that. So this is where you have like issue with that, and then we can as well question what we try to solve as a problems. So I started with my search bar, and I was not happy with what it is. But maybe the middle ground is not to be able to answer questions, but to offer much better, like so for example, the information retrieval system, which is cheap. So maybe this we can offer it. So we can offer something that is fuzzy matching in some way, and that would be very cheap to have, and we can probably have that. And one of the solutions is Algolia can provide such type of stuff, and I think that we'll explore it in the futures, and that should basically answer the questions there. But we have to evaluate as well how good this is. And I think that's it. Yes. Thank you.
Thanks, Guillaume. This was an awesome presentation. So we have one question in the Slido section. So do you see RAG-based search as an alternative or as a replacement to traditional search engines?
I have no idea. I assume that it will depend on how people. So so now I'm old. I'm 35 or 36. Let's say we are being used to search with, like, how we search in Google. So basically by terms-based search, and we're very used to that. Maybe the new generation that is coming is used to ChatGPT, and they just switch to natural language. And if we don't adapt our tools to that, then they will not know how to use our tools. So I wouldn't say there's one or another. So probably, yeah, if people start to get used to the other things, then we might need to look at like natural language questioning.
Okay, there are two more. Could you share some details on the re-ranking? What did you do? And did you observe big improvements?
So did I observe big improvement? I have no way to evaluate. So that's easy. I don't know. I hope so. So regarding the method itself, this is a cross-encoder from sentence BERT, and the way that it works is they train basically a classifier that gives a score to the things that you observe, and that was trained on the Bing request. So this is not fine-tuned basically on our use case. So it's something that we could fine-tune and that we should evaluate. But to do that, we need to have user data for being able to do that. So the only way to be able to do this, we need to collect data and then we can evaluate. But otherwise, that's the way that it's a pre-trained model that is a classifier that score basically based on data that come from Bing. So we are as good as Bing.
Okay, we have two more. I think we have time for both. So the next question is, why not use the scikit-learn GitHub repo instead of scrapers?
Because it's so some of the things we generate on the fly, so we have some more info. But at the end, like NumPy doc, we use the GitHub repo. We use like the original code, so we don't even like go inside the documentations. The examples, we use as well the Python file. We don't use the HTML one. The user guide is a more complex one because we generate things, and then instead of parsing the HTML, I will need to parse the RST, and basically I don't have tools. So this is the same, like is as developing is the same. So here we are using part of the GitHub repo at the end.
And we have one more at the end. Did you attempt any other forms of retrieval, such as Colbert v2?
So I assume with Colbert v2 is just that this is just a pre-trained model. So here, the different models. So instead of the sentence BERT, we could swap any type of models which is compatible. But again, we should have data to evaluate it to know if we just improve something or not. Because I mean, one of the things that we know is that those models are supposedly good at solving the task that they have been trained on. And here we don't know if this is the case. So until that we don't have data, I cannot answer basically like correctly.
Okay, thanks Guillaume, awesome presentation. One more round of applause for Guillaume.